Alright, now let's consider absolute value inequalities with greater than. So, an example might be the absolute value of some unknown question mark is greater than or equal to, let's say, 5. Okay? This is just arbitrary to understand the meaning of this. Our goal in this case would be to figure out all the possible values for this unknown question mark. So what this would mean is the distance, right, the left side of this side means the distance between question mark and 0 on the number line is, okay, so that's the left side of this statement. Absolute value of question mark means the distance between question mark and 0 on the number line. And then the right side of this means is greater than, let's change this to red, is greater than or equal to 5 units. I apologize for the handwriting there. Okay, so to interpret this on a number line, right, so we can understand what possible numbers question mark could be. It's easy to see on a number line. Let's mark 0. And question mark is a number on the number line, any number on the number line, more than 5 units away from 0. So let's 5 units away from 0 to the right is at 5, of course. So it could be any number further away than 5 or equal to 5 units. So it could actually include 5, okay? But I could measure 5 units to the right. I could also measure 5 units to the left to get to -5. And if I want to go more than 5 units to the left, I would have to shade outside of the -5 again, or equal to -5, because that's exactly 5 units away from 0. So now what we're going to do is use this number line and the fact that question mark could be here or question mark could be here, right? So our goal now is to drop, we're going to rewrite this inequality, drop the absolute value, and write a compound inequality to finish it. Okay? Now, we're done here, as a matter of fact. Question mark is less than or equal to -5. That's the left side of this, of course, right? Any number smaller than or equal to -5. Or, that's where the compound inequality comes in, and or goes here. In this case, it's got to be here or here, because there's two separate regions. Question mark is less than or equal to -5, or question mark is greater than or equal to +5. So notice there are no absolute values in this statement, and then at this point you're done. Let's go a bit more abstract, and instead of using something like question mark, let's use something with variables. So in this case we're trying to solve for x, right? And this whole 2x plus 1 is like question mark. So to interpret this on a number line, we know that 2x plus 1, its distance from 0 is more than 5 units. So here's 0. Here's 5 and -5. Those are the 2 points that are exactly 5 units from 0. But 2x plus 1, its distance is more than 5 units away. So it could be outside here of 5. This time it does not include the 5 because it's greater than 5 units, not greater than or equal to. It's also could be greater than 5 units this direction, so it could be any of the numbers here. So now 2x plus 1 lives here, or 2x plus 1 lives here. So what that means is 2x plus 1, if it lives over here, it's less than -5, or if it lives over here, 2x plus 1 is greater than +5. And now you have a compound inequality with no absolute values, and you can solve this using the ideas of compound inequalities. I'm not going to go through the details. I'll work it out here. I'm going to pause and work it out, and then I'll come back and show you the answer. So we solve each of these for x, and we get this statement. Now we'll write the answer on a number line. So x could be any number in either one of these shaded regions, and the original inequality would be a true statement.